Making smarter robots by first making them in the cloud. I'm Tonya Hall, and joining me is Dr. Roger Barga, General Manager, AWS Robotics. Welcome, Roger.
Thank you, Tanya. It's great to be here with you.
So, how are you involved with robots in your role at AWS?
I'm the general manager of robotics at AWS. Our team builds and operates a service called AWS Robomaker. This service helps our customers build better robots and get them to market faster with fewer production errors.
How are AWS customers using robots today?
We have a wide range of customers using robots. iRobot builds a wonderful line of vacuum cleaning robots, and they're also building other robots that will help you take care of your house. One of our customers is AWS Robotics. They have disinfecting robots for hospitals, which is really in high demand right now. Another customer is Woods Hole Research Institute, and they're building autonomous underwater robots for research and maintaining offshore wind farms. Another one of my customers is a small startup in the Bay Area building robots to take orders and deliver food in restaurants. Anywhere there's a dull, dirty, or dangerous task, we see our customers exploring how they can use robotics and automation.
Dull, dirty, or dangerous? Okay. What are the complicating factors behind designing and building robots today?
Yeah, so if you think about all of the technology that has to come together for a robot, you have the hardware on the robot itself, the firmware that's running on that hardware. In many cases, they're actually building the hardware custom, one-off for the robot. You have to have software engineers that actually write software that run on the robot. You have to have services to augment that robot, to operate it once in its production. I mean, there's a lot of technology that has to come together. It's almost very reminiscent of what the early days were like in building automotive. And this will mature, and it will evolve over time until pretty soon customers can actually focus just on what's unique to their robot. And that's what we're trying to look at is, what role can the cloud and cloud services play in allowing these developers to focus on just what's unique to their robot and not have to worry about all the other undifferentiated heavy lifting.
Explain robotic simulation and the benefits of first building robots in the cloud.
Yes. There are various uses of simulation when building and testing a robot, but perhaps the most important is to ensure that the robot will perform correctly. Physical robots are expensive. They operate out in the real world, often around people. And if the application that controls the robot has an error, the mistake could result in injury, loss of the robot, or both. So developers really want to make sure that their application will run correctly under all circumstances. Well, this is where simulation comes in, because a simulation contains a model of the robot and a model of the environment in which that robot is expected to operate. So the developer can install their software on this simulation of their robot, put it into its environment, and actually watch how the robot is going to operate and interact in its environment. And if they detect an error, they can update their software immediately, redeploy it to the robot in simulation, and iteratively test. So in a nutshell, it increases developer productivity, and it results in fewer software defects on the robot being put into actual production.
How do you verify that the simulation accurately mirrors reality?
Yeah. So this has been a big push in the development of simulation over the last decade, where the physics engines are getting more and more accurate, both for the hardware for the robot, but how the robot interacts with this environment. So if you look under the covers, simulations are not just these beautiful 3D environments you can see like a video game. The physics of the robot, the actuator, the sensor are all carefully modeled. So it's actually very close to reality. That continues to get better and better over time. So that the sim to real transfer is what they call going from simulation to the real world is high fidelity.
What role does machine learning play in the training of robots?
Yeah. So reinforcement learning, which is one of the three basic machine learning paradigms in which software algorithm will learn to perform a task through trial and error. So think about trying to train a robot to navigate through a restaurant or to grasp an item from a shelf. Simulation plays a key role here because we don't want our robot to try to do this out in the real world for all the reasons we talked about previously. So we can create a simulation and let the algorithm learn through trial and error in simulation to program the robot to perform that navigation task or that manipulation task. And because simulation is running in the cloud, we can actually run hundreds, thousands of simulations in parallel to accelerate the time to learn this particular task. And this is one of the reasons why we offer customers simulation as part of the AWS Robomaker service.
You referred to the fact that we've seen robots expand into homes, warehouses, and hospitals, for example. What are the next breakthrough use cases for robots?
Yeah. So even for the use cases that you just listed, we're still getting started. Less than 5% of equipment in a warehouse today is automated. Think about the other 95% where we could be augmenting the productivity of an individual worker, even around your house. Right now we have vacuum cleaners, but there's so many other tasks around us in our house where we could use the assistance of a robot. So I think there's many, many more options just for the areas that we have robots in today. But think about grocery stores, cleaning and restocking shelves continuously. There's a new robot being built for the space station. So it's still very much day one for robotics.
What about enterprise robots? What improvements will we see in how supply chain robots are interact?
This is an area that we're watching very closely, what we call ground mobility robots, autonomous ground mobility robots. We believe in the next 5 to 10 years, they're going to become the standard for moving material around through warehouses, supply chain. The customers we talk to, enterprise customers, very much want these robots to increase the efficiency of their operation, take the heavy lifting off their workers so they can move product around much more efficiently and improve the overall productivity of their enterprise operations. So I think that's an area that's going to move fast over the next 5 to 10 years.
Dr. Roger Barga, General Manager, AWS Robotics. If somebody wants to connect with you, maybe find out more about the work that you're doing, how can they do that?
Please feel free to reach to me through LinkedIn, and I'd be happy to exchange ideas with you and talk with you.
Thanks again for your time, Roger.
Thank you.
And find more of my interviews right here or at tonyahall.net. Thanks for watching.